Okay, here we go. Lesson 2, scale of the solar system. 2.1 is called solar eclipse. They say that the diameter of the sun is 1,391,000 kilometers. So, the diameter is 1,391,000 kilometers. Okay? The diameter of the moon, right here, is 3,475 kilometers. Now, diameter is from one edge of the circle to the other. Radius is from the middle to the edge of the circle. Diameter, right here, is the entire thing. Okay. The distance from the Earth to the sun is right here, 149,600,000 kilometers. So 149,600,000 kilometers. The question they're asking is, how far would the moon have to be from the Earth to appear the same size as the sun? So, with eclipses, in order for the moon to completely block the sun, it has to be like perfectly covering the sun from this perspective. So eclipses happen when you have three celestial objects basically right in line. So essentially we got to figure out, all right, how far would the moon have to be from the Earth in order to perfectly eclipse the sun? And the way you solve these problems is to set up what's called a ratio. So we got to set up a ratio. Okay, so the sun, the ratio of the sun's diameter to the moon's diameter will also equal the ratio of the distances from the Earth to the sun compared to the Earth to the moon. So what you need to do is set up the ratio first of the diameters. So the diameters $1,391,000 over 3475. So let's figure that out. So 1,391,000 divided by 3475. Figure that out. 1,391,000 divided by 3475 equals 400.288. So the sun is essentially 400 times as big as the moon. Which means in order for the moon to eclipse the sun, it's going to have to be the same ratio up here. So you're going to say 1,391,000 over 3475 equals, right here, 149,600,000 over x. This is x. So we got to figure out this distance. It's going to be the same ratio, is what I'm trying to tell you. So this ratio is going to be the same as this to this. So we already know this is 400.288 equals 149,600,000 over x. Imagine that's a 1. We're just going to cross multiply. So here you just cross multiply. Anytime you have a fraction equaling a fraction, you just cross multiply. So 149,600 equals x times 400.288. Got to divide by 400.288. These cancel. So your final answer is going to be 149,600,000 divided by 400.288. 149,600,000 divided by 400.288. You're going to get x equals 373,731. That represents this, so 373,731. That represents how far the moon would have to be from the Earth to appear the same size as the sun. And we're working with kilometers. Okay. Fun stuff. All right. The solar system problem is definitely kind of tricky. You had to be in class for this. It didn't really go that well, to be honest, because we didn't have much time. But I'm going to go get the cool down, and then we'll be done. Okay, let's do the cool down, and then we'll just call it a day. Okay, the moon orbits the Earth. So essentially the moon, the distance from the moon to the Earth is 384,400 kilometers. The distance from the Earth to the sun again is 149,600,000 kilometers. Yes. Yeah. Just grab the pads. Diameter of the sun is 1391000. That's the diameter. So on this one, you need to know what a diameter is. Okay, the question is, figure out the diameter of the Earth. So you got to figure out this right here, which we're going to call x. So what you need to do is figure out the entire distance compared to this. So how could you figure out the entire distance? Well, you could add them up, right? So 149 600,000 plus 384 400 equals 149 984 400 kilometers. This represents this plus this. So essentially the moon to the sun. So we need a ratio. A ratio is a fraction. We're going to compare this to this, and then we're going to compare this to this. So what you're going to say is 149 984 400 over just the Earth to the Moon, 384 400. That's going to equal this over this. 1391000 over x. So the hardest part of these problems is setting up the ratio. And then you're going to cross multiply. You will have 149 984 400 times x equals this times this. 1391000 times 384 400. It's 5.34704 times 10 to the 11th. This is scientific notation because the number is too big. But we still do the same thing. Got to isolate x. So 149 984 400. 149 984 400. These will cancel. Your final answer is going to be this divided by this. It's still right there. Just hit divide. Answer divided by 149 984 400 equals 3565.04. We now know the diameter of the Earth, which we defined as x, is 3,565.04 kilometers. So let's put it into a sentence. The diameter of the Earth would need to be 3,565 kilometers to appear the same size as the sun from the moon. Okay, it was a very quick lesson. We only had like 55 minutes. So anyway, that is the cool down plus the first problem from lesson 2. Now I want to go to the summary here. So let's take a look at this summary because this is really important. So to make a scaled copy of this figure right here, so we got this guy right here. So that its new height is 3 centimeters instead of 8 centimeters. You could just start calculating what the lengths of different parts of the figure would be. So one way to calculate the measurements of the scaled copy is to multiply every single length by the scale factor of 3/8. Because in order to go from here to here, we've got to like multiply every single body part by 3/8. That's what's going to be our scale factor. So let's look at AB. They used AB. The length of segment AB is 2.4 centimeters. How long is segment A prime B prime? So you just do 2.4 times 3/8. So 3 divided by 8 times 2.4 ends up equaling 0.9. So you go A times your scale factor equals A prime. So 2.4 times 3/8 equals 0.9. And that's how you do every single body part scaled. So that this little guy ends up being, every single part is exactly 3/8 as big. Okay, that was it. Lesson 2. We need more time, but oh well. It's is what it is. We'll get to a normal lesson in lesson 3. All right.